All right, so today we are talking about more application kind of these problems. I think you're good at these already, but I should review one for the video. If there's something in all of these, this and this and this, then you can cancel it out. So in this case, what goes into all of them? 3 does. So this will become a 2, this becomes a 1, this becomes a 1. And do I really need to divide by 1? No. 2 plus or minus. And do I need the 1 root 5? No, just root 5. Get that? Yes.
So when you have like big numbers,
Yep.
you know, like
Just bigger numbers.
whatever, and it, you put them like split them into
Yep.
and they both have 4 square roots. How do you know like if it's a 4 and a 4 for both of them?
I gotcha. All right, so let's say you're saying if you had a problem like this, 2 plus or minus square root of 200 all over 4. And you're thinking, okay, that 200 breaks down, but if I break it up into root 50 times root 4, and then the root 50 can keep breaking up, and the root 50 can break up into root 25 and root 2, how far do you keep going? Well, you keep going until you've only got numbers that are not perfect squares left. So like here, I'd have root 4, root 2, and 25. That's the only one that is not a perfect square. These two are perfect squares, so this would just be 5, and this would be 2. So it'd be 5 times the root 2 times the 2, which is really 10 root 2. So bottom line is, if you can guess the big number right off the bat, do it. But I just did 2 of them. You get how I had to do another perfect square and another perfect square. It'll work. Here's another one. Root, it's 72's got a lot of things in it. So let's say I break this up into root 9 and root 8, and then I'm not done, right? Because the common mistake would be to think I was done right there. But just keep going. And so the root 8, if I can keep going, I should keep going. So root 8 to root 4 and root 2. And I keep going until I got it perfect. So 3 times 2 is 6 root 2. And if that root 2 is like a root 12, I'd keep going. So you can just keep going down the page like this until you finally get to the right answer. All right, now back to this kind of a problem is where you have to do that. You'd look at the number like this, 32, and you could go, okay, that's 8 times 4. But then that really isn't great because 8 has another breakup. So I would use, what's an awesome one to use? 16 and 2. But if you do it the other way, it'll work. You just got to keep going. Okay, solve number 1 on this page. Then billboard your answer to me when you're done. Zoom in on it, please. It's hard to read that from where I am. Okay, keep it turned my way. Is there a 1 at the beginning of yours or not? Then you canceled it completely. You made it disappear. That 4, I know 4 goes into 4, but you don't just like make it disappear. 4 goes into 4 once, so there has to be a 1 at the beginning. That 4, Matt, should have canceled with some of the other stuff.
Oh, okay.
Your denominator should have canceled with the other stuff. No, wait, maybe I'm wrong. No, you're right. That's right. That's right. That's right. Sorry, I caught like 3 wrong ones in a row, so it goofed me up. Good, 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 good. Got to be a 1 at the beginning. Because when you take 4 out of everything, 4 goes into 4 once, so you put a 1 there. Yup, yup, yup. Still haven't seen yours. And your phone needs to go away during class. It is lunchtime, holy crap. Go to lunch.
We have one there.
Here we go. All right, so back from lunch, and on this one, I think you're all getting plenty good at this. Root 16, root 2, that'd really be 4. And then there's a 4 here, here, and here, or in that. And we had answers that you billboarded to me, 1 plus or minus root 2 all over 2. Okay, so I'm hoping that this next part, you can take some notes. You really do need to take some notes, because don't take them yet, because I want to make sure you get what you don't get. If I ask you to find the highest that the ball went, I know that you will know that that's the vertex, okay? But what's the technique you use? As in, what do I do? I got a problem and it says, what's the highest the ball went? And it gives you this thing. Okay, if it says that, what's the highest the ball ever went? What's the technique you need to use? Well, I'm going to tell you in a second. And what do I do if they ask me, when did the ball hit the ground? What am I supposed to do with this? When did the ball hit the ground? And I give you that. Do you know what to do? You will in a minute. And last is, if it's not here or here, then it's somewhere in the middle. And that's like, if I give you a certain time or a certain height, where is the ball at a given time? All right. Another thing I got to make sure you get before we start taking notes on this is not, the way they drew this with the little guy in here really makes it deceiving. It makes it look like this is a cannonball and that this is how far away the cannonball landed. False. Look at the label. It's time. That is not a distance. This is a time. It's how long the thing is in the air. We don't even know what angle they shot it up at. Okay, so if we don't know what angle they shot it up at, that would totally change how far the ball would go, right? I mean, if it was straight up in the air, this graph can still work for that. It'll tell you how far the ball is at a certain amount of time and when it hits the ground. Notice, it's time. It's not a distance. You can never tell from these how far is the ball. You can see how high the ball is, the height, but you cannot get a distance. This right here is when the ball hit the ground, because it's time. All right, so take out your paper to take some notes, your virtual paper. And here are get to this problem if you're in the notes for today. If you're not, you can just sketch this real quick. And I'm going to show you some notes that you ought to take, because when you're on the test and it's all of a sudden find the roots, and you're like, what am I supposed to do to find the roots? This is the notes that you're going to study right before that test. All right. This spot right here, where the ball is getting hit, this is Joe Mauer hitting a baseball. He throws it up in the air and he hits it. So of course it's off the ground when he hits it. He's not golfing. Okay, so it starts off the ground a certain distance. That's the y what? The y-intercept. So how do you find this spot? If that's the y-intercept, I'd like you to sketch this graph unless you have it in the notes. And then I want you to write here. It'll help you remember it. Set x equals 0. That's what you do. The y-intercept is when x is equal to 0. All I got to do is stick in x equals 0 into the equation, and you'll find how high the ball was in the first place. Okay, the next one is this, and I know it's the vertex, and I know that's where the highest spot is, and I know you all know that's called the vertex, but how do you find the vertex? If I'm given this, how do I find the vertex? There's a name for it. Complete the square. You know, that's that deal where you do half and square, you know, that thing. So really, if I'm going to extend the analogy of the little German boy, what he really is helping you with is finding the vertex. So when you're trying to find the vertex, ask half and square. And last, not last actually, almost last, that is when the ball hit the ground, and it's not how far the ball is from you, it's when did it hit the ground. And how do I find that? Well, that's the zeros, or the roots, or the solutions, or the x-intercepts. But still, how do I find them? Out of this, how do I find an x-intercept? It's where y equals 0. So I put a 0 right here. But still, how do I find that? The only thing that always works is quadratic formula. So I'm going to put down here QF, quadratic. I'm going to start calling it just for the next few days to try to pound it into your head. When the book, or not the book, and the worksheets ask you for the roots, you want to use the quadratic formula. I know, it's kind of annoying, but that might be a way that you could remember what to do to get the roots, is use the quadratic formula. Okay, there's one other place along the way, and that's that That could count for anything. And if you're somewhere in here, they're going to either tell you the X or the Y. So if you're somewhere in the middle, you take the given X or Y put it in. You put it into the equation. So they gave you this equation, right here. And if they said time is like 3 seconds, well, then I just stick 3 in for t. If they said the height was 9, well, I put the 9 in for h. And I figure out what the t must be. Now that's a little harder one because you'd have to move the 9 over here and then use the quadratic formula to solve it. It's the only thing that always works to get the roots. So if you're at a spot in between, that's not the peak and it's not the beginning or the end, then anywhere else in there, if they just give you an x or a y value, like they give you a time or a height, you just stick that into the equation and you'll figure out the other one. Yes?
Wait, so for A, what do you mean set x to 0? Like,
Because it's the y-intercept, and therefore you set x equal to 0. So take a look at this one. In here there is no x, but what is like x? So you set that equal to 0. Here, and you find out that, oh, it's 5. So does that make sense for a baseball hitting question? Starts 5 feet off the ground, yeah, he throws a ball up when he swings and hits it. He's fairly tall, it's going to be there-ish. Okay, those are the main points. So when they ask you, okay, they have a question on your homework today that's got a baton twirler, and they talk about when did the baton hit the ground? You should be going, oh, that means you want this, which means what should I do? Say it. Quadratic formula. When they say, how high did the baton go? And you want the vertex, and you should what? Complete the square. Ask half and square. When they say, how high was the baton twirler holding the baton in the first place? That's the starting value. That would be set x equal to 0. Time is 0. All right, so that's the toughest stuff for today. And these are always the toughest problems. Now, the good news is that our quiz that we have on this right after break, we aren't even going to include this part until later. We are going to have 2 quizzes. The first quiz will be on the relatively easy stuff. Then we're going to give you 2 days specifically just on that, what I just taught you. You'll have 2 more days to learn it, and then a test on the application ones. So they'll give you complicated equations and say, like, how high did the submarine go? Or when did the submarine hit the bottom of the ocean? Or yeah, how high was the ball when he started to throw it? So anyway, all right. And I don't think we need to do any more practice problems on that. I have one more that is a really challenging question, and I just want to demonstrate for you, because this, I think, frankly, is a little bit too hard for an average kid to be able to get. Now, some of you know that you are not an average kid, and you might be able to hang with it. I want you to just see if you can handle this. If I've got 130 feet of fencing, do you get that they just told me something in math-wise? What did they tell me? Perimeter. If they just told me the perimeter is 130, here's the hardest thing of all. How do I put that on my picture? I can't just draw a circle around it and say 130. That's not what I mean. I got to label these dimensions. Well, you pick one of them to be x, because we don't know what, we don't know what both of them are, but you pick one of them to be x. And the other one, we have to use the 130 and the x somehow. And here's how I would reason it through. Okay, if perimeter is 2 lengths and 2 widths, and I've decided in this problem that the perimeter is 130, and that's equal to 2 lengths, which I don't know, plus 2 x's, then the only thing I really don't know is the length. And now I can just solve that little equation for L. So then I'm going to take away 2x. 130 minus 2x equals 2L. And then I divide by 2. And there we go. My length is 130 minus 2x divided by 2. And you're even smart enough to know how to cancel that. Do you see that this and this and this all have a 2 in them? And therefore, this comes down to 65 minus x all over 1. So it's just 65 minus x. This is a pre-calc question. So now I'm close to the answer, but I'm still not done. I've got both my sides. Now, watch how this turns into a quadratic. It really is asking about the largest area possible. Well, I'm not sure exactly at this point if I was doing the problem where this is going, but I know that I need the area, and area is base times height. And the base here is 65 minus x times the height, which is x. And then here's where your ability to do what I just told you is important. When I multiply this out, I get 6x minus x squared. Do you get that that's an upside down parabola because it has a negative on the front of it? Do you get that? I just rewrote it. Do you get that that means it looks like this? And where would the largest area be? Which of those key spots do you think would be the place where I'd find the largest area? The very top, the vertex. Threw that in kind of a funny way, but basically, here, maybe I should go more like that. So that, the highest. So how do I find that? I just told you a second ago, and you took notes on it. How do you find the highest spot? How do you find the vertex? Complete the square. Could I complete the square on that thing? Oh, yes, I could. You get how that wouldn't really be that hard to complete the square on? Just have to factor out the negative. Okay. All right, I think you get the idea that that's a pre-calc question, so you'll be seeing those kind of questions next year. But it's got so many different layers. You had to use two separate formulas. You had to have a picture. You got to label the picture. It's just wanted you to see it and see how it could be a tough quadratic question. All right, so your homework for today is listed in our Schoology under today's date, which is 12-19, 19th of December. So I checked it over. It is not long. It is very reasonable sized. And the last problem is a baton twirler question I kind of referenced before. So when they ask what's the highest the baton ever went, you're looking for the vertex. So you should complete the square. When they ask for when did the baton hit the ground, that's the roots, and use the quadratic formula. All right, that's all I have for you for today.